Part 3.
So, now we've seen what MEMS are, let's look at something even smaller. We will move from the micro scale to the nano scale. And just as we had micro-electromechanical systems, we can have nano-electromechanical systems, or in other words, NEMS. The principle is the same, a combination of electrical and mechanical devices working together, but this time measuring from 1 to 100 nanometers. To give you an idea of this size, a human hair is around 100,000 nanometers wide. If you recall earlier today, I spoke about the two main uses of MEMS for sensors and actuators. Well, NEMS seem to have a lot of potential as sensors. Research has shown that they are highly sensitive detectors of various quantities such as mass, charge, energy, and displacement. To give an example, do you remember the MEMS used as a car crash sensor? Well, imagine that sort of device consisting of a mass attached to a hinge, but now imagine it much, much smaller. At this scale, the electrical circuit measuring the deflection of the hinge is capable of sensing the weight of an individual atom or molecule which is resting on it. It becomes a tiny weighing device. This sort of device would need to be built in a very similar way to how MEMS are built. The question is, how small can we go? Some people claim that there is no limit in terms of size, and that the same manufacturing processes used in MEMS can be used to produce NEMS, deposition and etching. I'm afraid that just isn't true. It's quite clear that the main problem in the development of NEMS is with the transduction element of the system. A transducer converts mechanical energy, for example a vibration, into electrical energy. Research has concluded that making transducers at a nanoscale level is not at all easy. The evidence lies in the fact that as electromechanical devices are made smaller and smaller, it becomes very difficult to create an efficient and finely controlled integrated system. However, there is another approach available for creating NEMS, using the chemical properties of single molecules. Perhaps the most exciting materials are carbon nanotubes. These are molecules of carbon allotropes. Allotropes are different forms which a chemical element can take. Carbon nanotubes look like very long, thin cylinders. Their diameter is only a few nanometers, but they can be up to several centimeters in length. They are extremely strong and have interesting electrical characteristics, acting as semiconductors in some circumstances. This means that they can be used to create nanotube-based transistors, one of the key building blocks in any electronic device. For example, a carbon nanotube can be employed as a digital switch, using a single electron. Some carbon nanotubes can also conduct high current densities, so can be seen as a type of wire, another fundamental component of any electrical system. We need to remember, however, that there are problems regarding the use of carbon nanotubes. First of all, when they're exposed to oxygen, their electrical properties change significantly. As a result, new environments will need to be developed for these electronic devices. Their conductivity also seems to be extremely variable, depending on various factors in the production process that have not been completely understood and which are not easy to control. Finally, carbon nanotubes may be extremely toxic, causing lung cancer when inhaled. But let's finish by looking at some of the potential of NEMS. Since NEMS are built so very small, their potential is huge. It is expected that they will make a significant impact on many areas of technology. And since they will be even more efficient, smaller, and cheaper to run and manufacture, they will one day perhaps even take the place of MEMS. So, all in all, I hope you agree with me when I say that MEMS and NEMS are very exciting fields of electrical engineering. Now, I'm going to set you a task which will involve investigating some of the points I've raised. I want you to do some research into some of the most common applications of MEMS. I've chosen 3 of these. The first one is a very common device, and I'm sure many of you have one at home, an inkjet printer. The second is a gyroscope. And the last application I want you to investigate is a portable blood pressure sensor.